number 9, we want to differentiate this. This is an implicit function. Why is it implicit? Both the dependent and independent variable, they are the same side. It should be, if even it's explicit, like the first one being differentiating so far, that your y into bracket 3s minus 4, I think, all raised by 3, that was explicit, because the dependent variable, which is y, is actually explicitly equal to the independent variable, which is s. But in this situation, they are both on the same side, where we still differentiate. Now what we need to do is just to differentiate it one by one, of course, by the rule of differentiation. Differentiation of this one is what? 3s squared. 3x squared, don't mind me, there should be a square around there. 3x squared, don't mind me, that's a mistake. 3x squared. Now that's the differentiation of that. Now differentiation of this one is what? 3y squared dy ds. If you are differentiating y with respect to dy ds again, if you are differentiating with respect to y, let me use that word, don't mind me, don't mind my language. Differentiating with respect to y, you know, when we differentiated with respect to s, we never put a dy ds. If you're differentiating with respect to y, there must be a dy ds there. That's what we show to us, that you differentiated with respect to them when running dy ds. I want to get a here now. Are we getting what I'm saying? And the rule around this, of course, I guess you know, and if not, you can, I think at the end of this video, I can actually drop my number, so that if you have any issue at all before the exam, you can always talk to me directly. So now let's continue. Now this place is where we have a little bit of issue. Now we want to differentiate. You differentiate 3xy with respect to x with respect to y, because you have both x and y there. You do that same function with respect to x, you do that same thing with respect to y. Are you here? That was what we wrote here. Do it with dy ds, do it with dy dx. Are we here? Now if you have 3xy, if you want to differentiate it with respect to s, your 3y will be a constant. Differentiation of x, 1x is 1, because it's not a trace power 2, so that will be 1. 1 times 3y, we get a 3 times y here, 3y. Do you understand? Simple. We just factorize the 3. Now the next thing we have is that, okay, we want to differentiate with respect to what? With respect to y. Then the 3s is going to be constant. Differentiation of y is going to be 1 dy ds. And that's why we have 3s dy ds. I guess that is easy. So joining all our answers together, we have 3s squared. I said it, 3s squared. Sorry. We have the 3s squared plus 3y squared dy ds minus 3 into bracket s dy ds plus y and all of that. So we bring the one with dy ds together, and the one that are not having dy ds, put them to one side. 3s squared is not having dy ds, but it is positive here. Come here is going to be negative, and the minus 3y. You know, when you bring up when this minus 3 multiplied this, that will be minus 3s dy ds. Minus 3 multiplied this, that's minus 3y. Minus 3y is not having dy ds. Then you take it to the other side, but it was minus before, then it's going to be more positive. Why this one? You join it to this, and all having, and that's what we did here. 3y squared is having dy ds, minus 3s is having dy ds. The next thing we did was to factorize the dy ds. That's the common thing. Don't factorize the 3o. It's only the dy ds we need to bring out. Yeah. So the next thing, divide both sides by what you have left, and then we get something as beautiful as what we have around this place. Just dividing, when you factorize, then divide both sides by 3y squared minus 3s, 3y squared minus 3s. Your divide ds is going to be what? Now, minus 3x squared plus 3y over 3y squared minus 3x. But minus 3 is common to everything. So that was how we factorize 3 here. When you factorize 3, you have 3 into bracket minus x squared plus y, then over 3 into bracket y squared minus s. So 3 cancels 3. And we are left with what? Minus s squared plus y over y squared minus s. Now on to number 10, but I want you to see the question. I want you to see, they said the radius of a circular ripple made by dropping a stone into a pond is increasing at the rate of what? 8 centimeters per second. That's what that should have been. 8 centimeters per second. And 8 centimeters per second. So at what rate is the area enclosed by the ripple increasing when the radius is, the initial radius is 25? Leave your answer in terms of pi. That's the question, that's the question, that's the question. So they give us the rate at which the radius is increasing. They said it is increasing at the rate of what? 8 centimeters per second. And they gave us the radius of the movement. That's the initial radius, the radius of that thing itself, of that ripple that was formed. The radius is 25. Don't forget, we use small increment here. Idea of small increment. Are we together? Yeah. Is somebody getting it? And what do we want to do here? We say, okay, what is area itself? What are we talking about? We are talking about ripple and all of that. A circular ripple. A circular ripple. Don't forget, a circular ripple. So we are using area of a circle. Area of a circle is what? Pi r square. Because it says circular ripple. Had it been it says spherical object, you guess area of a square, area of a sphere. Had it been it says cylindrical object, you use area of a cylinder. Are you get what I'm saying now? So now the area of this, and what do we want to do? They've been talking about rate. Anytime you hear rate, you are thinking of differentiation. Rate, because the definition of the differentiation itself is what? The rate of increase in the vertical to increase in the horizontal. So that's how you get the rate we are talking about right there. So what do? Differentiate the function a with respect to r. Differentiate the function a with respect to r. But don't forget, somebody is saying, where do we put a dt here? We use what do you call it? We use actually what am I going to say? We use chain rule to get this. Yes. We wanted to get the dA area. We wanted to get the rate. So that would be a differentiating a with respect to r times differentiating r with respect to t. So that was what we use. So our dA dt equals the ADR times the r dt. That's chain rule. Don't forget that. We applied chain rule to get the answer there. So the r dt. The RDT is actually what? Sorry, the ADR is actually differentiating a with respect to r. The ADR is going to be, of course, with respect to r. R square is going to be 2r, just like what I said before. Pi will be a constant, then differentiation of r square will be times 2r. So that is where we get the 2 pi r, but the DRDT is still there. So, but they already gave us the DRDT to be 8, and they gave us the initial radius to be 25, so substitute it into this place. The RDT is 8, this one is 8, and R is 25. So 25 times 8 is obviously what? 200 times 2, 400. They say we should leave it in terms of pi. So that's going to be 400 pi centimeter square per second. Why? The unit of area is square unit. So centimeter square per second, because we are finding the rate. Next up here, we want to integrate this. But let me show you the question. I just want you to see it for yourself. Number 11. A curve with dy ds equals this. Given at the points minus 1,5 lies, find the equation of the curve. We want to find the equation of the curve. But there's a mistake I made when I was typing my question, computing the answer. I did root x plus 1 over root x. So just change it in yours, put x square, and we'll show you how to go about that. That's what I was saying. So they gave us a dy ds. What do we need to do? From there, multiply both sides by ds. I wanted to get something for y. You know, from here, your dy ds. So your dy ds is this. So my dy is going to be just like we say in cross multiply. That will be the whole of what I have root s and then with dx. So integrating both sides, you get, if you integrate dy ds, you get y back. So equals to integration of the right hand side with respect to s. I guess you get my game there easily. Oh, you got me 12. Now let me continue. Now, integration of root s is what? Still, root s is the same as s raised to power half. So that will be half plus 1 over half plus 1. Are we together here now? Half plus 1 is 3 over 2. That will be s raised to power 3 over 2 divided by 3 over 2 divided by 3 over 2 divided by 3 over 2. At the end of the day, you want to change it, division to multiplication. That's where we get 2 over 3. That's where we get this one from. Are we together here now? So somebody is saying, yes, if that is how we get the other one, but how do I do this second? How do I do this second? Now, how do I do it? I'm coming. That's just going to be a little bit slightly different from this. Not really big deal though. Now, this one here, we have 1 over root s, and that is the same as 1 over s raised power half. So that will be s raised power minus half. So that will be minus half plus 1 over minus half plus 1. Minus half plus 1, you have a 1 whole thing, and you remove half there. What are you left with? Half. So that will be s raised power half divided by half. Of course, when you want to change this to multiplication, bring this one up, bring this one down. That will be 2 s raised power half. And s raised power half is root s. That will be 2 root s. Somebody is now saying, what if we want to leave it as a question they gave us? How would that look like? Because this is not the question they gave us, right? What if I want to do it the same question they gave you? Okay, that's not a big deal. Now for you, if you want to do that, we have 1 over s squared in the question, so that will be the same as what? S raised power minus 2. That will be minus 2 plus 1 over minus 2 plus 1. So we get s raised power minus 1 all over minus 1. And there's a positive sign in front of s, a positive divided by negative, that will be minus s raised power minus 1. That's the same as what? Minus 1 over s. If you do it properly, you get minus 1 over s. Easy as that. So the next thing we want to join our answer here to the answer here. That's what we did here. But that's a general derivative. We need to do it at the point they give us. They give us a point of x equals to 1 and y equals to 5. So we need to do it at that point. Now for this one, they give us, we did the general point for the whole of them. It's like, what do I mean by general? That will work for anything. The integration, the value we get with plus c, that will work for anything. But they want to limit us to a point so that we get a definite integral, we get a definite function. Like what we did here. We want to get a definite function. And what's missing? You already get this, it's only the c value we want to get. So once they give you the point it lies, you're able to get the c. Just substitute y for y, s for x. So our y equals something, our y is 5, and our x is what? Anyway, you see s, put 1 there. So 1, that will be 2, 5 equals 2 over 3, 1 is by 3 over 2. 1 is by anything is 1. So 2 over 3 times 1 is 2, 2 times 1 is 2, plus 2 over 3 times anything, times 1, sorry. 2 over 3 times 1 is what? 2 over 3 times 1 is 2 over 3. And 2 times 1 is 2, plus c. Now I'm running this function the normal way, of course. What do you do here? Just trying to play around it. So you have your 2 over 3 plus 2, 2 over 3 plus 2. So make this over 1, do the LCM, 3, and then 3 and 3, 1, 2 times 2 times 1, 2, plus 1 and 3, 3 times 2, 6. That's how we get our 8 over 3 here. The next thing, bring this one here for we to get something beautiful for C. So C is going to be, don't mind me, I want to make room for that. C is going to be, what do we do? Just the same thing. C equals LCM 3. This one is the same as over 1. 1 and 3 times this 15 minus 3 and 3, 1 times this 8. 15 minus 8, 7 over 3. So substitute 7 over 3 for the equation we get to y plus y equals 2 over 3 s raised by 3 over 2 plus 2 root x. This one should have been a root x root 1. So root 1 is still 1 anyway. And plus c. So substitute c for c there. So substituting c, we get this is the equation we want to get. Next one, this is question 12. Question 12. We want to find, don't forget, in question 12 we were told to find the equation of the curve is y equals to s plus 8 over x squared. Find the area of the region enclosed by the curve, the x-axis, and the line x equals 1 and 2. When you have this kind of question where they give you find the area of the curve enclosed by the curve, the x-axis, and 2 points in x. The curve, the x-axis, and 2 points in x. Just put those 2 points as the limit. The least point as the lower limit, the higher point as the upper limit, like I did here, and then differentiate the function. That will be the area you want to find. It's going to be it's going to be something like this: integration from a to b of y dx. Are we together now? What's the y they give us? The function they give us here, that's our y. So we integrate this normally. Integrating to s, don't forget the rule of integration, that we want to integrate s raised power n with respect to x. That is going to be what? S raised power n plus 1 over n plus 1 plus an arbitrary constant. Are we together here now? So by that rule, that will be now 2x raised power 2s is going to be 2x 1 plus 1, because initially the power of x is 1 over 1 plus 1. So I guess the 1 plus 1 will be 2 cancels 2, so we are left with x squared here. And the same thing, 8 over x squared. Let me tell you how we go about that. Let me tell you how we go about 8 over x squared. Let me tell you how we go about 8 over x squared. I don't want you to just watch the video and then later you have issues still getting something along the line. And if there's a part you don't understand, go over it over and over again. It's so simplified, and I bet you get it easy easy, no stress at all in understanding the concepts around these beautiful things we have here. Are we together here now? So let me continue. I want to show you how we get that, how we get our now integration of what? 8 over s squared, and that is the same as 8 s raised power minus 2 by the law of indices. So that's going to be what? 8 s raised power minus 2 plus 1 over minus 2 plus 1 minus, very good. Now minus 2 plus 1 is, so somebody is saying that's minus 1, and you're correct. So that will be 8 s raised power minus 1 over minus 1. Positive divided by negative is what's going to be what? Minus, and then we have minus 8 times s raised power minus 1. By law of indices, s raised power minus 1 is the same as what? 1 over s. So 8 minus, so that will be what? Minus 8 times 1 minus 8 over s. That's how we get this one here. So the integration, natural integration of the function itself, the normal integration of the function is what? Joining this to this. So that is x squared minus 8 over x plus c. That's the normal integration. So let's just substitute the limits. You know how to run about limits when you have integration and you have f of x from dx with respect to s from a to b. That will be f of b minus f of a. That's how to run limits. Put the upper limit minus putting the lower limit. That's how we go about limit. What's the upper limit? 2. What's the lower limit? 1. So substitute 2 into what we got here. What do we get? That will be 2 square minus 8 over 2. 2 square is what? 4. 8 over 2 is 4. 4 minus 4, 0. Now substituting 1 that will into this same place. That will be 1 square minus 8 over 1. 1 square is what? 1. Minus 8 over 1 is 8. 1 minus 8 is actually minus 7. So that will be, I told you that will be upper limit minus lower limit. So that's the upper limit is 0 minus the lower limit. So that will be 0 minus 7. And then we get the 7. So the area of the region is 7 square units. Why do we put square unit? Square is for anything area. When you find area, you square it. When you find a volume, you cube it. So that's how we get the square unit.